Okay, in this video we're going to have a look at how we test cations using sodium hydroxide. Okay, so here's my list of cations. Ignore the bits in red for the moment, but here are the cations we're going to do. And basically each of these tests involves us adding sodium hydroxide solution to the sample. And if these cations are present, we observe and we use the observations to decide and identify on the cation. Okay, so each one of these is adding sodium hydroxide. The only two to be aware of that are different is aluminium, where we add the sodium hydroxide initially, and then we continue to add more sodium hydroxide, and we'll come to why in a moment. And this bottom one here is the ammonium ion, and we add the sodium hydroxide here to the sample. We gently heat it, and that just means we can hold the test tube in our hands. The heat from our bodies will cause that to be warming up. And then over the top of the test tube we have a piece of damp red litmus paper over the neck of the test tube to test for any gas that could be produced in that reaction. Okay, so and then the middle ones, they're all just standard, just add a few drops of sodium hydroxide and observe. In terms of what we see happening, let's just go through each of these. I'm not going to do equations for them all, just some of the key ones within this. But you can see here for aluminium that we take the aluminium 3+ ion, we add the hydroxide. Now because it's a 3+ ion, we have to have 3 lots of the negative hydroxide ions in order to make this charge cancel out and form a precipitate. The solid, remember precipitate is an insoluble solid, so for the precipitate to form. Okay, this one we then can add more sodium hydroxide, and this precipitate will react with the extra sodium hydroxide and dissolve, so your precipitate will then go back into solution and disappear. Okay, so the precipitate that we get initially is white, and then that precipitate will dissolve if the ions are aluminium ions. Next one down. Okay, let's take this whole bunch as a section because this is just adding sodium hydroxide to the sample. I'm only going to give one equation here because you can work the rest out quite quickly. So what we have to do is we add enough sodium hydroxide ions to cancel out the charge on the cations. This is Cu2+, therefore we have 2 lots of hydroxide ions. Down here you've got ion 3+, therefore you'd have 3 hydroxide ions to make that charge become 0. That forms a precipitate in each one of these, and the precipitate that forms is a different colour. So we go from white to blue to green to brown. You can see here why this is important, because when we add excess sodium hydroxide, the white precipitate dissolves. Here it doesn't dissolve, it remains. This means that although they both give a white precipitate, the tests are still unique and therefore can identify a calcium ion and an aluminium ion from each other. Okay, and the bottom one, the ammonium, you can see here that we take the ammonium, ion, I've got my plus charge on that. We take the ammonium ion, we add 3 lots of hydroxide, it forms ammonia and produces water. Ammonia is a gas, that's why we have the dampness over the top, so we don't get a precipitate, but the gas that is produced will then turn that damp red litmus and make it go blue, because it's going to behave as a base and let us know that the ammonia is being produced, and the ammonia is produced because of the presence of the ammonium ion. Okay, have a go, make sure you can write all these equations, absolutely crucial, practice, get those done. And again, a way to help to remember this, okay, so remember the ions in order is a crab could fetch 2 furry animals. So we need fetch 2 because this is ion 2 and then we have ion 3. So a crab could fetch 2 furry animals. And then a way to remember the colours that we're forming over here is the white bear greets the brown albatross. And I've got this image in my head, this big white polar bear that's saying hello to the brown albatross as it flies overhead. Okay, 2 ways to remember the orders again.